Yeah, hello. I'd like to welcome you to our talk. Our talk is about modularity, and Vaadin's OSGi R6 layer. My name is Florian Pirchner. I'm from Vienna, Austria. I own a very little company with a companion. It's called the Lunifera GmbH. And
my name is and I work for Liferay, and I've been working, as Sona said, I've been working before with the Vaadin in my past projects. So this presentation is something like that we have doing together with Vaadin, and Florian and I together with the Vaadin, with the OSGi.
About 2 months ago, Samsa had a really great idea, writing a Vaadin OSGi layer based on the OSGi R6 specification using Prototype Scope. So we joined, I implemented the servlet side, and Samsa did the same for the portlet stuff. And this is the agenda of the talk. It's not an OSGi talk. We are talking about modularity. We are talking about class loading. We take a look at features of modularity that are really great and available in OSGi. Yeah, and at the end, for I think about 10 minutes, we are going to make a demo about the new Vaadin OSGi application, the OSGi layer. Well, we are going to start to define some rules for modularity. I thought, where to begin? I thought, yeah, let's use Wikipedia. Let's look at Wikipedia about modular programming and see what Wikipedia tells us. Modular programming is a software design technique that emphasizes separating the functionality of a program into independent interchangeable modules, such that each contains everything necessary to execute only one aspect of the desired functionality. So I did an excerpt from it. So what means modularity? Modularity means that you have to separate your functionality into modules. A module needs an interface. For now, do not think about Java interfaces. Just think about the interface like metadata. The interface, the metadata, expresses elements provided by a module and elements required by other modules. Let's call this relationship. And modules need to be interchangeable and independent. I'm doing OSGi trainings, and I have 2 pictures. It's not that easy to explain what modularity means, but it's pretty easy to explain what's anti-modularity. Here you can see anti-modularity. It's very close to the cube, to the stone cube of 2001, a space odyssey. What we see here, it's not modularity. That's a monolithic stone. Modularity is something more flexible, something more dynamic. Modularity, you can think about it like your neurons in your brain, billions of cells interacting with each other. The neurons are so-called modules or bundles, and they have relationships to each other, and they can interchange information. So let's start with our simple rules. We have modules. I painted 3 modules up there. Now let's check our excerpt. We have separating functionality. Yeah, that's true, since every of this module has a distinct functionality. Every of this module is used for a special case, for a special calculation, for instance. And a module has elements, as Wikipedia told us. Elements, in the sense of Java, consists of the metadata. The metadata is the interface, not the Java interface. It's the information which defines the relations. We have resources in there, like pictures, like files, like all stuff of resources, and for sure we have Java code, we have bytecode in there. So the metadata expresses what elements will be exported, will be provided by this module. And it also defines the requirement. A module may have requirements to run. For instance, I need a different class to let it do some calculations. And this is true for every module, not only for one. Every module provides us with the exported and imported features. There hasn't to be one exported or imported features, but it gives us the possibility to do so. So let's take a proof. Here we have a module A, B, and C. Export is green, import is orange, and A uses B and B uses C. So we could use our module definition to express a module system. C exports elements to the module B, and A requires information from B, which is expressed by module B. So we can put out the metadata stuff. Now, Wikipedia states that modules need to be interchangeable and independent. What means interchangeability? It's a very weak version of modularity we are defining here. Module A requires a module B. Now we have 3 different modules, and each of these modules is from a different vendor. So now you have to be careful which information you are exporting by a module. Yeah? Since every module B needs to export the same information. These are wired by their names. That's a very, very weak way of modularization. We also could add versions. Yeah? The module A requires a module B with version bigger than 1 and lower than 3. And yeah, indeed, the modules are independent. They encapsulate information, they encapsulate functionality, but they may require other modules. So each of these modules is interchangeable and independent. So stop. We heard about OSGi. We heard about so cool features. What's about the package export, the package imports, versioning of packages, a module lifecycle. I heard there are also services, and we can express services by declarations. Yeah. That is what OSGi gives us. So, if you're talking about modularity, the main concept of modularity in Java means class loaders. What is a class loader? A class loader reads bytecode from somewhere and lets the JVM create a class for it. And a class loader may load a class only once, exactly once. If you need to reload a class, you have to trash your class loader. A class is defined by a tuple of the FQN. The FQN expresses the bytecode, tells the class loader what is the bytecode to load, and the loader. So if you're loading the same class, so the same full qualified name, with a different class loader, you're getting a different class, which is not castable. There are 2 strategies for class loading. There's the parent-first model. Everybody of you most probably knows about the class loaders in the GEE system. In Java, we have the bootstrap class loader. It loads the runtime jar stuff. Then we have the system class loader. It loads all the class bus stuff. And now we're getting into the application server. Most of application server, all application server have a lib. We put in there all the common stuff. And each enterprise archive has also its own class loaders. Think about an enterprise archive with a lot of different EJB jars in it. And the var left and the var right would need a common class. So the same class loader has to load the EJB class. Otherwise, you won't get a local interface in the sense of JEE in this time. So what happens in the parent first? the var1 class loader wants to load the myEJP class. It first delegates to the EJP class loader. The EJP class delegates to the app server class loader, and so on. We are arriving the bootstrap class loader, getting down. App server class loader couldn't find it. Then the EJP class loader will find the class, pass it to the var1 class loader. In the other case, the var was loaded. We assume this. The var2 class loader likes to load the same EJP class, delegates to the EJP class loader. EJP class loader says, hey, I have it in my cache, and returns it properly. So we can say the tuple of FQN and class loader is the same for var1 and var2. I think that's clear. But is this modular? No, that's not modular. It can't be modular, since we do not have an interface. We do not have metadata interface. Yeah? We do not express our dependencies. We're getting a class loader, and we can use this parent class loader approach to look for our bundles. Maybe some of the class loader will find the class. Otherwise, you're getting a class not found exception. There is the Wildfly server. It does something very, very similar to OSGi. The interesting part is there is JBoss OSGi, or JBoss GI. Yeah? About 2 years ago, it was JBoss GI. Now it's called JBoss OSGi. And they did really something great. They have their own module loader. It's not so great like OSGi, but it's a module loader, and they implemented the OSGi core specification by their own module system. So here we can see the classical Java Enterprise Edition architecture of class loaders. What is Whitefly doing? Whitefly is rotating the whole stuff and says, hey, my var1, my var2, my EJP, my ERR, all this stuff, I'm putting it into modules. Yeah? And so we can say, yeah, we have clear dependencies. Yeah? We have metadata which expresses who can see who. For sure, even Whitefly and even OSGi are using a bootstrap class loader, a higher class loader. Sure, you need to load, for instance, classes in the Java package or the Sun packages by a common class loader. Otherwise, you're getting two different tuples and you can cast. Yeah? That's the reason why you need a bootstrap class loader. If you know about OSGi, here is the way you're expressing your dependencies, how you define your modules in the JBoss Wildfly module system. It's much, much simpler to do it in the manifest in OSGi. So now let's look at the delegating model, how classes are loaded. We assume we are loading var1 tries to load the myEJP. It first delegates to the EJP module. It doesn't delegate to a parent. No, it delegates to a different module. The EJP module says, yeah, it's there, yeah, and passes it back. That's also true for the var2 module. So now you could say, hey, what's about the ERR module? Why isn't the ERR module called to be asked for the class? You could using OSGi, you could say, okay, I'm going to re-export the dependency the EJP module has to the ERR module, and then the EJP module is allowed to re-export it. But be very careful. You're getting in a big mess if you're using re-export in OSGi. If you think I should use re-export and you're not really sure, don't do it. Don't use re-export. So yeah, that's pretty cool. Yeah? Now we have modular Java Enterprise Edition. No, only the implementation of the GEE spec is modular, but GEE itself isn't. modular. We have no way in GEE spec to express dependencies like we need it to do to be modular. And honestly, to make GEE more modular, we would need to change the JEE specification. Otherwise, JEE won't be modular, independent what technique you're using to implement the GEE stuff. So if you want really modularity and perfect modularity, if you want the queen of modularity, you have to go for OSGi. OSGi is really great. Yeah? It takes some time to dive into the thinking of modularity. But if you did for a few weeks, yeah, you'll see OSGi is pretty simple. OSGi isn't that hard to learn. For me, it's much harder to use a Java Enterprise Application Server than using OSGi, because I'm missing the thinking about modularity there. So 2 slides about OSGi. It's not a OSGi talk. OSGi is a dynamic modularity layer. It has implemented lifecycle management, not only for bundles, for modules. Modules in OSGi are called bundles. Not only for bundles, even for services. We have semantic versioning. We may export and import packages. So we have a deeper level. We do not think on the level of bundles. Still we do, but we have a more fine-grained way to look for it. With the new BND tools by Neil Bartlett and Peter Greens, we have even great tooling. Yeah? BND tools, the new versions 3.3. Yeah, it's really fine. We built the Vaadin stuff on top of BND tools, and we have declarative services. So the best practice pattern, if you're using modularity, is use services. Yeah? Use services. Concentrate on services. What does it mean? A service is an interface. Yeah? We have an API module. I have an API module, for instance, iFoo service. Yeah? And this API module just exports this interface. Now we think in the sense of Java interfaces. Yeah? It's a Java interface, iFoo service. It exports not it exports the package. Yeah? It doesn't export the class itself. Then we have implementation. The implementation API relates to the API. Sure, we need to implement the API. And we have a consumer. The consumer also depends on the API module. And the consumer registers at the service registry and say, hey, OSGi, as soon as there pops up an iFoo service, please inject it into me. And as soon as this service gets registered at the service registry, nevertheless, if you do it by declarative services or you register the service manually, it becomes injected into the consumer module. So we have dependency injection with a very, very light coupling. Yeah, it follows the pattern. Do not call us, the Hollywood paradigm, I think. Do not call us, we call you. And now we're coming to the Vaadin part. So I see 10 minutes left. That's great. Is Vaadin modular? Yeah, Vaadin is modular. Vaadin is modular since version 6, and now we almost have version 8. We have 7, 8, I think. Yeah, it's really modular. We're using it a lot in all our projects. We're using the combination about Vaadin and OSGi, and it's a perfect match. It's a perfect match. In Vaadin, we have different jars, and all of these jars are bundles, yeah, are modules. And they have a really good setup. Yeah? The dependencies are clearly defined between the different modules. So now we're going into our live demo. I will show you the implementation for the R6 servlet. What did I do? You see the red square. That's a Vaadin UI. It's a simple Vaadin UI. It contains a tab sheet. And the counter and the address book tabs are injected by services. So the base UI, I call it base UI, said, hey, as soon as there is a sub-application, please inject me all the sub-applications that are there. And I, as base UI, I'm going to add the tabs. Samsa, can you explain your?
This application is a chat application that I'm going to show you. So this is a simple example of the Vaadin application that has been built from several modules. And our idea when we do these applications is that we could have a common application made with the Vaadin. I mean Vaadin application. And you can take that Vaadin application if it doesn't have anything Liferay specific or anything that would bind at the Liferay, it would work in other OSGi container which is R6 compatible. That's our target. And this application actually has several modules. It has a portlet. Actually, it doesn't have a portlet. It has only UI. And then there's a module about how to display this chat window. And during my demo, I'm going to be able to demonstrate you how that feels in coding.
Now let's start. Here you can see the BND tools workspace. It's pretty messy. It's my development workspace. Oh, yeah. I can see it. Now it's pretty messy. It's my development workspace. I'm using it. I used it yesterday evening to do some stuff. We are concentrating on this for project using BND tools based on these packages. 3 bundles are generated, or 4 bundles are generated. You can see them there. Here you can see the Vaadin base UI and adding sub-application, removing sub-application is just done with add reference. Yeah? With the add reference, we tell OSGi, if there is a service of type I sub-application, inject me all of them. So now I'm going to start. All bundles. Here you can see the application. No, this one. No. Different one. Yeah, this one. Here you can see the application. That's the Vaadin address book sample. You may know. That's the classical sample. And there up, that's the counter. And both of them are expressed by OSGi services. And now we have a look what happens if I'm going to stop one of these services. I'm going there, say LB for list bundles, XR example, and now let's stop the address book. Yeah? Let's stop the bundle 8. So what will happen now? We are using WebSockets. That means that any change in the OSGi container will immediately pushed up to the UI. So I stopped it, and the address book sample is gone. Now I can start it again, and it's there again. So I can start with an empty container, empty OSGi container, and I just need to install all my sub-applications in there. And there is another really great feature implemented. It's the web console. In the web console, we're doing all the configuration. If you are familiar with Vaadin, you say an alias, a description, context path, widget set, page title, push mode, automatic, push transport, WebSocket, and you can configure all that stuff based on the web console. I can change it to foo up there, say save, go back, reload, and it's gone. Now I'm calling it, and it's not a bug. No, it's not a bug. It's a feature. It's a development feature. Now we just get an exception. Yeah. Now, yesterday evening, I prepared the talk for today, and I added an unwanted feature in there. So, Samsa?
Yeah. I have a similar kind of demo here. but it's running with the Liferay, basically. The code base is different, but ideas are same. So we have this chat application, so here are 4 minutes. So we have a like chat, and you can write things here. And it should be working. Come on. Okay, let's do the refresh. We're quiet too long. Do we have an issue here? It has been working today so well. Okay, let's continue. Basically, what you can do also is that, as you showed, you can actually shut down part of the Vaadin application. What I can do here is I can shut down these components. I can list. Vaadin, grep Vaadin. No, sorry. I'm not supposed to help. It's the last one anyways. Stop. So now you see the portlet is still there. Actually, Vaadin is there. But when we start it, we will come back. If we do coding perspective here, we have a code here. So I have something here. So you see that there's 3 columns. And we save it. And it's deployed. It's visible right away. If I'm deployed here, it disappears. If I drag and drop it, it's through the Developer Studio, it's there. So, and this is not shareable. This is standard OSGi deployment. It goes all the deployment cycle. And sometimes when you look at this Vaadin application and look at the sizes, so basically one of the things is that Vaadin is outside of these your applications. It's a bundle that your application is using. So it means that, example, a very small Vaadin application, I have an example here, which is the one page Liferay application displays the username. How big is the size? How is the application? What is the bundle size? Guesses. 10K. Oh, you are so high. It's a 5 kilobytes. So we are not talking about megabytes here. You can put 1,000 of these there. And you see how fast they deploy. You see what kind of developer experience we have. And when you have OSGi with any container, if you use Vaadin, you can use Liferay, you can use other R6 containers. And we are together doing this project, and we actually invite you to join us.
And we think the first release will be there in 2 to 3 weeks.
Yeah, that's our goal, yeah.
Yeah, but then we have a pretty good documentation also, yeah. If you're interested, just write us an email or...
basically, GitHub, Vaadin, OSGi will be a home. Now there's some... So this will be the home. The code what I'm showing, it's not here. It's my repository, but it will be merged in these 3 weeks.
Yeah, I can see 7 seconds left. That was pretty good.
Okay, so we are out of time. We have a half-hour break right now. You can ask your questions to them over the break time. So let's go have our coffee break.
Thanks a lot.
Thank you.